Hello, friends. Welcome to the Awesome Algebro. Today's lesson is going over the law of exponents, which has several important distinctions when dealing with exponents. We have product of powers, which tells us if we see two exponents, if they have the same base, theoretically, we could just add their exponents. We also have power of a power, where we raise a exponent to another power. We could just multiply the exponents. Or we have quotient of powers, where if we're dividing exponents with the same base, theoretically, we could just subtract the exponents. We also have negative exponents, which tell us that negative exponents will always flip to the other side. And we also have rational exponents, where we just make sure we put everything in the corresponding place. Now, before we get intimidated, please understand these concepts are extremely easy, but you got to follow what I'm doing. Okay, product of powers. Once again, if you have two exponents with the same base and they're multiplied together, theoretically, you could just add the exponents. For example, 3 to the fourth power times 3 to the second power should give us 3 to the sixth power. Just like 5 to the third times 5 to the seventh should give us 5 to the 10th. Now, you may ask, how does this even work? How is this even possible? Right. When we look at these situations, we look at the exponents because we're trying to simply determine how many times was that number multiplied by itself. All we're asking is how many times did we multiply that number? So let's take a look back at our first example, which was 3 to the fourth times 3 to the second. Now, if we expand it, if we just look at it from a different aspect, 3 to the fourth power means what? And please don't tell me 3 times 4. 3 to the fourth power means multiply the number 3 by itself 4 different times. 3 to the fourth power means 3 times 3 times 3 times 3. Great. But what does 3 to the second power mean? That means 3 times 3. But altogether, how many times did you multiply the number 3? Altogether, you multiply the number 3 6 different times. Okay, let's try it again with another problem. And in total, all we're looking at is how many total times did you multiply your number? Okay, let's look at the other example we saw earlier. 5 to the third power means multiply 5 times 5 times 5 times 5. Multiply the number 5, 5 times 5 times 5. But 5 to the seventh, tongue twister, means multiply 5 times 5 times 5 times 5 times 5 times 5 times 5. But altogether, even though my tongue is getting twisted, altogether, how many times did you multiply 5? Altogether, you multiplied the 5s 10 different times, 5 to the 10th power. And we're just looking at how many total times did you multiply. Okay, let's go to the next one. Quotient of powers, which I think is actually one of the easiest. It's saying if you have the same base and you're dividing the exponents, theoretically, you could just subtract the two exponents. Like, if you had 8 to the seventh power divided by 8 to the fifth power, well, theoretically, if you just subtracted the two exponents, you could have gotten just 8 to the second power. Now, how does this work? This works because when you expand it, you will notice that the numbers at the top and the numbers at the bottom, they cancel each other out. And you can simply count how many multipliers are left over, whether they're at the top or whether they're at the bottom. All right, let's take a look. So our previous example, 8 to the 7th times 8 to the 5th. Well, 8 to the 7th means you multiply 8 7 times. Multiply 8 times 8 times 8 times 8 times 8 times 8 times 8. And at the bottom, 8 to the 5th power, where you multiply 8 5 different times. Now, if you have the same number at the top and the same number at the bottom, you are going to cancel things out. For instance, 8 top and 8 at the bottom, they cancel out. Now, that doesn't mean 0. It means 8 divided by 8 is just 1. So because we don't want to write the number 1 over and over again, we cancel them out. So cancel, 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 cancel. What do we have left over? We have 8 times 8, and it's 2 8s, so that would be 8 to the second power. Now, all you're counting is what's left over. Okay, now let's take a look at another example. What if you have n to the second power divided by n to the sixth power? So you got 2 at the top, but 6 at the bottom. So they will cancel each other out. So the 2 at the top, cancel, cancel. And what do you have left? You have n to the fourth. But you have n to the fourth at the bottom. If n to the fourth is at the bottom, then you would write it as 1 over n to the fourth power. Okay, because n to the fourth is at the bottom. It wasn't at the top. Okay, let's go to a power of a power. A power of a power is saying, theoretically, if you have a base and you raise it to another power, you could just multiply the two powers. So if you have 10 to the second raised to the fourth, theoretically, you should have 10 to the eighth. Just like if you had this complicated formula, 3x to the fourth, y to the fifth, all raised to the second power. That means everybody inside gets raised to the second power. And we'll take a look at a question like that in a second, where 3 is now to the second power, 9. X to the fourth raised to the second power, 8. Y to the fifth raised to the second power, y to the 10th. Now, how does this work? It really helps if you expand the problem, because it's really just an expansion of multiplication. It's like saying each exponent is multiplied by the other exponent to find the final result, okay? And so let's take a look and expand it a bit and see if we can understand it a little bit more. So 10 to the second power raised to the fourth. That means you're going to get 10 to the second power 4 different times. So 10 to the second power means 10 times 10. And you're going to do that once, 10 times 10 twice, 10 times 10 3 times, 10 times 10 4 times, because it said to the fourth power. But all together, how many times did you multiply 10? 1, 2, 3, 4, 5, 6, 7, 8. 10 to the eighth power. So theoretically, you could have just multiplied the two exponents. Okay, theoretically. Okay, let's jump to the next one. And I put expand the problem because sometimes if you just write them out, it'll help you understand it a little bit more. Okay, let's look at our example from earlier. And I think you really smart kids are really going to understand this. 3x to the fourth, y to the fifth, all raised to the second power. Well, the second power means we need to write that problem down 2 separate times. So let's do that. Let's write it down once. Let's write it down twice. Now that we have written it down 2 different times, let's simply do this. Let's put things together that are the same. Let's put the numbers with the numbers, the letters with the letters, 3's with 3's, numbers with numbers, A's with A's, B's with B's. Let's put everything together that's the same. And when we do that, let's put together the numbers. So the 3 and another 3. Let's put together the x's. X to the fourth, another x to the fourth. Y to the fifth, another y to the fifth. If we put the 3's together, 3 times 3 is 9. X to the fourth times x to the fourth, x to the eighth. And I'll see if you can guess this one. Y to the fifth times y to the fifth should give us y to the 10th. And that's exactly what we get. Okay, 3 times 3, 9, x to the fourth, x to the fourth, x to the eighth, and then y to the fifth, y to the fifth, y to the 10th. Okay, next one, negative exponents. It's really just a way to tell us to flip the exponent to the other side. Whenever you see a negative exponent, if it was supposed to be at the top, flip it to the bottom. But if it was at the bottom, the negative exponent was at the bottom, now you would flip it to the top. So that's how negative exponents work. Negative exponents are just little guides, little signals that tell you to flip it to the other side, okay? If a negative exponent was at the top, you would flip it to the bottom of the fraction. But if a negative exponent was at the bottom, you would flip it to the top. So that's negative exponents. Positive exponents, though, they stay wherever they are. If you see it at the top, keep it at the top. But if you would have seen a positive exponent at the bottom, then just keep it at the bottom. Okay, let's look at this somewhat complicated question. 4a to the fifth, b to the negative third, c to the negative second. Looks complicated at first until you realize, wait a minute. He said keep positive exponents where they are, but keep negative exponents, flip them to the other side. So that means the 4, the A, the B to the negative third, C to the negative second. Okay, so 4, we should probably keep it where it is. A to the 5th, keep it at the top where it is. B to the 3rd, flip it to the other side. C to the 2nd, negative 2nd, flip it to the other side. Let's see. So 4 to the first power stays at the top. A to the 5th top. B to the negative 3rd bottom. C to the negative 2nd bottom. Okay, those two will stay at the top. Those two will stay at the bottom. Giving us 4, A to the 5th at the top, B to the 3rd, C to the 2nd at the bottom. Okay, so if it's negative, flip it to the other side. If it's positive, it will stay where it is. All right, let's take a look at this complicated one, but not too complicated for you. 2/5, x to the negative 1st, y to the 8th, z to the negative 4th. So 2 to the 5th, x to the negative 1st. Okay, now we just need to figure out what will stay where it is and what will flip over. So 2 to the 5th, the 2 will stay at the top, the 5 will be at the bottom. X to the negative 1st, flip to the bottom. Y to the 8th stays at the top. Z to the negative 4th, flip to the bottom. There we go. Now, we just need to see what stays at the top. Okay, 2 is at the top. Y to the 8th is at the top. Now, you might ask, well, Mr. Towns, what about the 1s? How come you aren't doing anything with the 1s? Well, anything times 1 is just the same number, so we don't have to worry about the 1s too much. And at the bottom, 5, x to the 1st, z to the 4th. And there we go. 2y to the 8th, and then at the bottom, 5x to the 1st, z to the 4th. Now, radical exponents, this is going to go super quick because it's really just asking us to just put things in the matching spots. If it matches in the same spot, just put it in the same spot. So we just simply have to match the correct letters to the corresponding spots. That's really it. So we have something like this. Okay, just the M here. Just make sure the M matches here. That's it. N matches here. Just make sure it matches there. So just match the positions. Okay, so we have this situation, 8 to the 5th to the 4th power. 8 to the 5 over 4th power. Just make sure we put the 5 here, put the 4 there. Just match them in the right spot. That's literally it. Okay, all right, let's see if we can knock out this problem. We're going to do 2. What expression is equivalent to 1/4 times 8a to the 4th, b raised to the 2nd power, times 2a to the 3rd, b to the 5th? Okay, let's work it out. So let's expand it. And we're going to start here because we know that's a power raised to a power. So we're going to expand that. It says to do it to the 2nd power. So we're going to write it out twice. We're going to put 1/4 times 8a to the 4th b once, 8a to the 4th b twice, and then write the rest. Now at this point, we're just going to do this smart thing. Put things together that are the same. Put numbers with numbers, A's with A's, B's with B's. That is it. So how many numbers do we have? 1/4 is a number, 8 is a number, 8 is a number, 2 is a number. So we'll put those together. Now, what else should we put together? A to the 4th, A to the 4th, A to the 3rd. Okay, what else should we put together? B, another B, and a B to the 5th. And if we are to work those out, 1/4 times 8 times 8 times 2. Now, you can put this in Desmos if you want to, or your graphing calculator. What is 1/4 times 8 times 8 times 2? Should give us 32. But 8 to the 4th times another 8 to the 4th times another 8 to the 3rd. Just think about if you expand it. 8 to the 4th, 8 to the 4th, 8 to the 3rd should give us 8 to the 11th. Then B times B times B to the 5th. How many times did you multiply the B's? That should give us B to the 7th. Okay, last question. What expression is equivalent to 20a to the 10th, b to the 2nd, divided by 4a to the 7th, b to the 9th? All right, let's work it out. Don't get intimidated. Just put things together that are the same. So we'll start here. Put the numbers together. 20 divided by 4. What is 20 divided by 4? It's 5. Okay, so those are the numbers. Put the numbers together. What else should go together? Well, the A's. Those are the a's. A to the 10th divided by a to the 7th. Well, a to the 10th divided by a to the 7th should give us a to the 3rd. And then let's put the b's together. Okay, b to the 2nd divided by b to the 9th. Now, in this situation, there's more b's at the bottom than there are at the top. Okay, so if we're going to write this, we should have b to the 7th at the bottom, not at the top, at the bottom. So that should be 1 over b to the 7th. Now, if we had to put it all together, though, the 5 goes at the top, the a to the 3rd goes at the top, the b to the 7th stays at the bottom. There we go. And because I don't want anybody to freak out, please know you did do it correctly if you thought that, Mr. Townsend, when I did b to the 2nd and b to the 9th, I got b to the negative 7th. That is correct. But remember, that also means b to the 7th at the bottom. All right, everyone. I hope that helped. Hey, friends. Thanks for watching the awesome Algebro. Please be sure to like, comment, share, and subscribe for the most awesome algebra tips available. And again, thank you for making me a part of your day.